Okay, so today we're going to talk about how to graph quadratic inequalities. So we've already talked about how to graph quadratics, and that's just the U-shape and N-shape graph. And so if you want to get precise points, this is a general idea of what the graph is going to look like. What you would do is you would ignore the y is less than, but take the x squared minus 6x plus 10, and you could plug that in your calculator into y equals. And when you hit enter, you can see by going to, or hit graph, sorry, you can see by going to the table, by hitting second graph, and you can find all these different coordinate points to get a better idea of the shape of this graph. One thing I want to point out is that because we have this less than symbol, and it's not less than or equal to, remember, without the equal to symbol, we're going to use a dotted line when we draw our shape. So let's try to remember that. We learned that with linear, with straight lines. So we would draw a dotted line here because it is not equal to, meaning any point on this parabola, on this U-shaped or N-shaped graph, would not be a solution of this. And then this is why it is a less than. When I think of less than, I think of below or underneath or down. And so I'm going to shade everything that's below or underneath or down on this graph, meaning any point underneath that U-shaped graph is going to be a solution to this. So I could pick -10, -4, and when I plug in, when x is -10, I'm going to get that -4 is going to be less than whatever I get here. So all of these points, infinite number of solutions underneath this U-shaped graph is going to be a solution. Meaning that when I pick a solution, say 5, 20, that is not going to be true. When x is 5 and y is 20, 20 will not be less than whatever this value is. And so anything on the U-shaped graph or inside the U is not going to be a solution. And so if you're asked to test coordinate points or give me one that is a solution, you're looking for inside the shaded region. One point that's not a solution, you're looking for inside the U-shaped graph. Now, what if you have a U-shaped graph that's pointing up like we do in number 2? And number 2, notice that it's greater than or equal to. So because of that equal to sign, we're not doing a dotted line. We're going to use a solid line here. But because it's greater than, when I think of greater than, I think of like up or above or higher. And so I'm thinking above this graph, anything above it. So not below it, not underneath the U-shape, but on top or above this U-shape. And so that's everything on the inside, in this case, of your quadratic function, your parabola, or this U-shaped graph. Now, meaning if I were to test a point, it could be any point on the U or any point inside of the U that's going to satisfy this question. And so, or this inequality. So if you picked a point outside, underneath, like 3, -5, that would not be a true statement when you plug in 3 for the value of x. -5 would not end up greater than or equal to whatever you get when you plug in 3 for x. And so here is how you graph quadratic inequalities. 2 things to make sure. Remember the difference between a dotted line and a solid line. But also, kind of the new part here is not new in the sense of shading with linears, but it's new with quadratics. That less than or equal means that we're shading down or under or below. Greater than or greater than or equal means we shade up or above. So anyway, go Tigers.